Hello, I'm Hardy Flickinger with LJ Star Incorporated, and our tutorial today is on how to ensure sight glass safety. If improperly specified, installed, or maintained, sight glasses can be the weakest link in a processing system because they can limit observation capabilities, require frequent maintenance or replacement, or make it difficult to illuminate the vessel in which they're installed. Additionally, sight glasses can fail, endangering workers and causing extensive destruction and system downtime. When glass fails under pressure, it is sudden and catastrophic. Glass can fracture at 5 miles per second. In systems made primarily of metal, such as pressure vessels or process piping runs, the weak spots are generally sealing joints and glass. Typically, failure of an industrial sight glass on a piece of equipment or within a piping system will halt the entire manufacturing process and force downtime until the equipment can be repaired or replaced. This failure often requires scrapping the process media in sanitary processes. That could mean millions of dollars in lost revenue. An industrial sight glass failure has the potential to be extremely dangerous. Even minor cracks, scratches, or abrasions of the glass can be a source of weakness within the glass, which can lead to failure. A catastrophic failure can cause severe injury or death, as well as costly downtime and negative environmental impacts. There are 3 main steps to ensuring sight glass safety. Number 1, choosing the right sight glass for the application and application standards. 2, installing the sight glass properly. And 3, routinely and carefully maintaining sight glasses. Let's take a look at step 1, choosing the right sight glass for the application. Choosing a sight glass based on the type of glass depends on a number of things. The application's temperature, how the process chemicals react to the glass, and the level of pressure involved all play a role. Here are the operating temperature ranges for some common optic materials that have been used in sight glasses. Obviously, not all materials are equally appropriate for all sight glass applications. Here is some additional information on the various material options available, including the temperature, thermal shock resistance, corrosion resistance, abrasion resistance, pressure capability, and impact resistance. There are 2 types of sight glasses, a conventional glass disc and a glass disc fused to a metal ring during manufacturing. Conventional glass can often fail as a result of being subjected to significant tension. With fused sight glass windows, the compressive force the metal ring puts on the glass exceeds the tensional force, and as a result, the sight glass will not fail. The metal ring squeezes the glass and holds it in radial compression. Glass can tolerate very high levels of compression. Here we have a comparison of the 2 most commonly used sight glass materials, borosilicate glass and soda-lime glass. I'll talk about each one separately and their individual benefits. Before the development of borosilicate glass, almost all sight glasses were made of soda-lime glass, a common, relatively inexpensive glass, which is used in bottles, light bulbs, and window panes. This glass is typically made from silica, soda, lime, magnesia, and aluminum. Soda-lime glass is widely used for low pressure, low temperature, and non-caustic sight glass applications. Borosilicate glass, which was originally developed by Corning under the brand name Pyrex, offers high strength, the ability to withstand high temperatures, high corrosion and chemical resistance, and high thermal shock resistance. In addition to sight glasses, Borosilicate glass is used in cookware, lab equipment, and glass pipe. It's made from silica, boric oxide, and alumina. The boric oxide enhances its stability and helps to bind the rest of the elements together to prevent leaching. Here's an example of a bad sight glass choice. An independent inspector for an injectable drug maker mistakenly recommended installing more powerful lights for inspection vessels for cleanliness. In fact, the light ports were made of soda lime glass that had etched so badly that light could not shine through them. The one shown here also shed a glass shard into the process vessel. Another concern from a safety and product contamination standpoint. It should be noted that sight glasses are often light ports, which can go long periods of time in between inspections, as long as the light is operating normally. These problems can go unnoticed until frequent routine inspections are completed. Don't spend all of your time looking through the window, also spend some time looking at them. This formula will allow us to calculate how thick your sight glass window should be based on the pressure differential it will encounter. Generally, the thicker the glass, the higher the pressure it can withstand, and the lower the resultant overall stress. Annealed glass is glass that has been slowly cooled to prevent buildup of internal stresses, so it can be cut and further processed. After annealing, the glass can be further strengthened by tempering. There are two methods to temper glass. In the first one, chemical strengthening, a chemical solution is applied to boost the mechanical resistance of the glass. In the second method, thermal tempering, annealed glass is heated to approximately 680 degrees Celsius, almost at softening point. The glass is then quenched or cooled with a steady high-pressure flow of compressed air. This process quickly cools the surface, which goes into compression, while the core is allowed to cool more slowly, which then goes into tension. This process makes heat-tempered glass 3 to 5 times as strong as annealed glass. Rapidly cooled, fully tempered glass, when fractured, releases the tensile energy stored into the core and breaks into many fragments, much like automotive safety glass and glass backboards for basketball. If, instead of cooling the glass rapidly, it is allowed to cool slowly, it becomes only twice as strong as annealed glass. When fractured, these broken glass fragments are linear and will normally remain in the frame. Thermally tempered glass is often used in conventional sight glasses. In addition to tempering, glass can also be strengthened by placing it in mechanical compression. Fused glass sight glass windows, like Metaglass, offer high pressure capabilities and high safety margins. The strongest type is made from duplex stainless steel and borosilicate glass. This combination creates the highest compression. During heating, the glass is melted within the metal ring as the ring expands. As it cools, the glass and the metal ring fuse together. When the unit cools, the glass hardens before the metal ring shrinks back to its original size. This process places the metal ring in tension and the glass in uniform radial compression. Glass can tolerate very high levels of compression. Radial compression improves the performance of the glass because it offsets the effects of tensile stress. Under the strong compressive force, the glass, in effect, becomes elastic. The metal ring enhances failure resistance because mounting and sealing pressures are applied to it rather than the glass. Even when bending forces extend beyond the metal ring into the glass remains elastic and able to tolerate bending. Fused glass sight glasses won't shatter, even under extreme bending force. They can fail safely because they retain elasticity. Any number of factors can contribute to sight glass failure, like the one you see here. A sight glass failure can be attributed to improper assembly design, such as flanges that are too thin, too few bolts, a cushion gasket that is too soft or too thick, or inadequate glass thickness. There's also the potential for improper installation, such as over-tightening, uneven torquing, or debris trap between the vessel and the sight glass. Manufacturing defects, such as flanges or glass that don't have flat and parallel surfaces, can lead to failures. Incorrect use and mishandling that introduces microscopic surface defects can also require premature replacement. Reusing conventional glass discs and gaskets during maintenance and inspection can create an unsafe situation. Both glass discs and gaskets should be replaced during maintenance. Unknown variables during processing, such as thermal shock, shadowing, and overpressurization, can also cause early failures. Glass can simply degrade over time due to corrosive chemicals or erosion from friction from the process media. Finally, the clamp-on sight glasses, which are widely used in the pharmaceutical and food production industries because they allow all components to be disassembled for easy cleaning or reconfiguration, the wrong clamp can lead to problems. Always choose clamps designed to withstand the level of pressure the sight glass will experience. These are the critical standards you'll see cited on sight glass data sheets. DIN is a German standard, ASME is the American Society of Mechanical Engineers, and BPE stands for Bioprocess Engineering. Now we can move on to step 2, installation. The operating safety of sight glasses depends to a great extent on installing them correctly. The gasket seating surfaces in the flanges must be flat and smooth. Ensure the gasket edges are not trapped by the flange gasket recess wall. The glass disc must be centered in the flange assembly with the correct gaskets seated on its top and bottom faces. Only use gaskets that are in good condition, flat, and free of dirt and grease. Before tightening nuts or bolts, double check that the cover and base flanges are correctly aligned and surfaces are parallel to one another. Tighten the nuts or bolts progressively in diametrically opposed pairs. Check the installation and operation manual of the sight glass for details on the tightening protocol. Once the assembly has bedded down under operating temperature and pressure, it may be necessary to retorque the nuts and bolts. When installing quartz sight glass discs, follow the manufacturer's instructions carefully. Quartz should never be used without the appropriate holder. Putting quartz under compression outside of its holder may result in cracking and failure. After dismantling a sight glass assembly, in accordance with DIN 7080 standard requirements, you must replace the glass disc and gaskets with new ones before assembly is put back into operation. This is particularly important where pressure vessels and/or aggressive media are concerned. On hinged and threaded sight glass assemblies, always check for functioning seals. Fused windows can be installed back into service pending satisfactory inspection. Sight glass wipers are often used to clean process media from the inner surface of a sight glass. If a wiper is used, check the assembly is correctly installed and that it's only being used within the temperature and pressure ranges specified. Check the drive housing periodically to ensure a good seal. If necessary, tighten the threaded bushings, replace any defective seals, and clean the wiper arms and blades to remove accumulated foreign matter. Sight glass wipers are often paired with spray devices to enhance their cleaning capabilities. The temperature of the spray fluid should be as near as possible to that of the vessel contents. You should never use cold spray fluid on hot glass surfaces. The differing thermal states could cause a failure. Here are more installation tips. Never use glass that is scratched, chipped, or otherwise physically damaged. Glass seating surfaces must be flat within 0.005 with a smooth surface. Flanges must be rigid. Do not allow the glass to contact metal when assembling. Gaskets must be new, clean, and smooth. And use gaskets of the same diameter and be sure to keep them centered. Never tighten bolts on a sight glass while equipment is in operation or when the sight glass is hot. Follow a regular tighten sequence to ensure even loading of the glass. Allow a maximum difference of 1.5 foot-pounds between bolts during tightening. Tighten only enough to produce a positive seal against the process pressure. Bolts may need to be tightened after initial cycling of the vessel. Finally, let's talk about regular sight glass maintenance and its impact on safety. Sight glasses must be included in your overall preventive maintenance program. Their wall thickness should be checked regularly, using visually or by ultrasound measurement. Where a dish shows any damage, it must be replaced during the next vessel shutdown. Regular checks of the sight glass should lead to less downtime for each particular vessel. This will promote a routine for glass exchange suited to the process. To examine the glass for scratches, shine a very bright, concentrated light source at an angle of about 45 degrees. Anything that glistens should be inspected closely. Scratches that catch the fingernail or any star or crescent-shaped marks that glisten are cause for replacement. Sight glasses that appear cloudy or roughened after cleaning should be replaced. Always inspect sight glass frames and flanges for corrosion or product buildup. Once a conventional sight glass has been removed from its mounting, discard the glass and gaskets and replace with new glass and gaskets. There's only one exception to this rule. Metaglass safety windows may be reinstalled, following the instructions provided for this procedure. Keep glass clean using commercial clean glass cleaners. Never use wire brushes, metal scrapers, or harsh abrasives to clean a sight glass window. Do not attempt to clean glass while equipment is in operation.